Hello everyone, this is Babitha, working as Assistant Professor in the Department of ECE in Institute of Aeronautical Engineering. In this session, I am going to discuss the terminologies as well as definitions which are going to use in the feedback amplifiers. So in the case of feedback amplifiers, we are going to discuss about what is meant by feedback and why we are moving for the feedback even though we are having the amplifier for the amplification purpose, and what are the different types of feedback amplifiers, and the general characteristics of the negative feedback amplifiers. Why? Because negative feedback only more preferable compared to the positive feedback. So that's why we are going to discuss the general characteristics about the negative feedback only, and effect of feedback on amplifier characteristics, and different types of feedback amplifiers. Those are voltage series, voltage shunt, current series, and current shunt feedback configured amplifiers we are going to discuss here. So along with this, we are also going to discuss about oscillators. So in the case of oscillators, what is the condition required in order to design the oscillator, as well as what is the basic requirements in order to generate the signal from the oscillator, and different types of oscillators. Here we are having two types of oscillators, RC oscillators as well as LC oscillators. So in the case of RC type oscillators, we are having RC phase shift oscillator as well as Wien bridge oscillator. And while coming to the LC type oscillators, we are going to discuss about the analysis of LC oscillators in the Hartley as well as Colpitts oscillators. So these oscillators are used to generate the waveforms, and the feedback amplifiers are used to nullify the disadvantages of amplifiers here. So next we will see what is the feedback here. So feedback is nothing but from the amplifier. If you take one particular amplifier circuit, okay, so the output of the amplifier we are indicating with the V0, and the input of the amplifier we are indicating with Vi. So some part of the output signal, that is V0, again we are giving back to the input of the amplifier. So this path or this part of the signal we are indicating with the feedback here. Okay, so why we are doing this particular thing means in order to produce or get the desired output from the amplifier circuit or any electronic circuit, we are utilizing this feedback here. And what are the shortcomings of the amplifier? It is nothing but what are the drawbacks of the amplifier circuit here. So in the case of amplifier circuit, the gain variation is occurring due to the output voltage. So output voltage is varying means the corresponding gain is also varying here. So how this gain is varying is depends upon the supply voltage, how much we are providing for the amplifier, and as well as any temperature variations across the circuit, or any variations in the component parameters of the amplifier. So because of these reasons, there is a variation of gain in the amplifier circuit, but that is not required here. Always the amplifier should provide the stable gain. So that is the first drawback of the amplifier. And sometimes along with the required output waveform, we are also getting the distortion along with the required waveform. Okay, so once we get the distortion in the output waveform, that will give the non-linearities in the operating characteristics of the amplifier circuit here. It is nothing but once we get the distortion in the output waveform means the overall characteristics will be changing across the output of the amplifier circuit. And the amplifier can able to introduce the noise also. So these all are the defects of the amplifier. In order to overcome these demerits of amplifiers only, we are adding feedback to the amplifier circuit. And next, what is voltage amplifier? So here the name itself indicating here the amplifier which is able to produce the output as the voltage. that particular amplifier we are calling it as the voltage amplifier. So in this case, both the input signal as well as the output signal both are in terms of voltages only. Okay, it is nothing but the output voltage proportional to the input voltage you will get in the case of a voltage amplifier. And this proportionality factor does not depending upon the source and load resistance of the amplifiers here. In the case of voltage amplifier, it can able to amplify the applied input signal, that is without affecting the source and load resistance in the amplifier circuit. So that indicates the voltage amplifier. So the gain parameter of this voltage amplifier we will indicate with AV, and the input is VI and the output is V0 here. And next, what is current amplifier? So current amplifier is nothing but which provides the output current proportional to the applied input current. It is nothing but in this case input is current as well as the output is also current signal here. Both are currents. So here the gain is indicated with AI here. So in this case also, when performing this current amplification, it will not depending on the magnitudes of source resistance as well as the load resistance of the amplifier circuit. And next, what is mean by transconductance amplifier? So the amplifier in which the output current, that is nothing but the output signal is current here, proportional to the signal voltage, that is nothing but input is the voltage. That is nothing but here the output transconductance we will indicate with the GM, and that is the ratio of output current to input voltage. That is nothing but whatever the input voltage we are applying to the amplifier, that corresponding output current we can expect from the amplifier output. And in this case also, it is independent of the magnitudes of source and load resistance of the amplifier circuit here. And why it is called as transconductance means the two parameters are from two different sections of the amplifier here. The current belongs to the output side of the circuit and voltage belongs to the input side of the circuit. So that's why we are indicating with the transferring the parameter from one side to another side. Because of that reason, we are calling it as the transconductance amplifier. Suppose we are having both the parameters are input side or at output side, directly we can say it as the conductance amplifier only. That is not an transconductance amplifier. And next, what is transresistance amplifier? So in the case of transresistance amplifier, we will indicate with RM. So in this case, it will give the output is the voltage. Okay, this output voltage is appearing for the corresponding applied input current across the amplifier. So this is V0 by II indicates the transresistance amplifier here. Okay, so here also the voltage is the output parameter and current is the input parameter. Because of that reason, we are calling it as the transresistance amplifier. Or else, if it is both our input side parameters or output side parameter, so that we can say it as the normal resistance amplifier. And in this case also, the output voltage we are getting proportional to the applied input signal current of the magnitudes of source and load resistance. So here it is depending upon the source and load resistances here while providing the output voltage. And next, what is positive feedback? So here in the case of feedback, I have already mentioned for the amplifier, we are providing some input signal and we will get the output signal, and we are taking some part of the output signal and giving back to the input signal. This path we are calling it as the feedback. So this, when we can call it as this as the positive feedback means whenever the input signal is, whenever the input signal is added with the feedback signal, then we can say it as the positive feedback. or else we can also say the feedback energy, that may be the voltage or current in phase with the input signal, so that we can call it as the positive feedback. That is nothing but the input signal as well as the feedback signal, whatever we are getting from here, both are in phase, so that we can say that amplifier is in the positive feedback connection. And or else we can also say, in this case we are able to add the input signal as well as feedback signal, and the combination of that additive signal we are giving back to the input of the amplifier in order to get the desired output across the feedback amplifier. And next, what is mean by negative feedback? So in the case of negative feedback, the negative feedback amplifier circuit, the same signal I am applying and the output voltage I am getting, but in this case, the fraction of the output signal I am taking here it as the feedback signal. So the input signal and the feedback signal, we will take the difference of the two signals, and that again we are applying back to the amplifier circuit in order to get the desired output across the feedback amplifier. So in this case we are performing the negative operation, so that's why it is the negative feedback. Or else we can also say the feedback in which the feedback energy is either voltage or current is out of phase with the input, and this opposes it is called as negative feedback. That is nothing but the input signal as well as the feedback signal are 180 degrees phase shift between input signal as well as the feedback signal. 180 degrees phase shift will be there in the case of negative feedback amplifiers. But in the case of positive feedback, there is no phase shift or 0 degrees phase shift between the input and feedback signals. And next, what is voltage series feedback? So here voltage series feedback is nothing but from the amplifier circuit, the output is voltage. In this case, in the voltage series feedback amplifier, the output is always voltage only, it is not the current. So some fraction of this output voltage we are applying back to the input of the amplifier in series, okay, within the series connection with the input voltage through the feedback circuit, so that that particular circuit we can call it as the shunt driven series feedback amplifier circuit, or else voltage series feedback amplifier. That is nothing but both the voltages we are connecting in series to the amplifier input, so that we can call it as the voltage series feedback amplifier. And next up, what is voltage shunt feedback? So in this case also, the output is the voltage signal. Output is the voltage signal. So the some fraction of this output voltage signal we are connecting parallel to the input of the, okay, we are connecting parallel to the input of the amplifier, so that this particular connection we can call it as the voltage shunt feedback amplifier. So here we will get the VF. Both are in parallel. Both the voltages we are connecting in parallel here, or in shunt connection we can say. Here both the voltages are in series, so that we can call it as the voltage shunt feedback amplifier, and we can also call it as shunt driven shunt feedback amplifier. And next, what is current series feedback? So in the case of current series feedback, the name itself indicating the output of the amplifier is current here. Okay, the output of the amplifier is current here. So here the output, some part of the output is applied in series with the input signal here. Okay, voltage to the feedback circuit. So this is also known as the series driven series feedback circuit. And next, what is current shunt feedback? So in this case, a fraction of the output voltage in series with the input voltage through the feedback circuit. So this is also known as series driven shunt feedback amplifier circuit. So that is nothing but depends upon the which type of connection we are utilizing in order to take the feedback signal as well as input signal to the amplifier. We can able to differentiate 4 types of feedback amplifiers. So while performing this feedback operation on the feedback amplifier, we are going to utilize the sampling process as well as mixing process. Sampling always we will do at the output side of the amplifier, and mixing always we will do at the input side of the amplifier. And next, what is mean by sampling? So sampling is nothing but we are taking some part of the output signal and again we are giving back to the input of the feedback circuit. Okay, so it is done at the output side of the feedback amplifier. I have already mentioned sampling always we will done at the output side of the amplifier here. And always sampling is different for voltage and current. If suppose we are doing the voltage sampling means we'll go with the shunt connection. If we are doing the current sampling means we should go with the series sampling. Okay, it is different for current as well as voltage. And next, what is mean by mixing? So mixing is nothing but addition or subtraction of feedback signal with the source signal of the amplifier circuit. So mixing always done at the input side of the feedback amplifier. So this mixing also different for voltage as well as for current. So if it is voltage mixing, always we have to take the series connection between the input signal as well as the feedback signal. And if it is the current mixing, then always we have to take the shunt connection between the feedback signal as well as the source signal of the amplifier. So these connections are very, very important in the case of feedback amplifiers or in order to design any kind of feedback amplifier. And next, give the gain equation of positive feedback amplifier circuit. So this is the gain equation. AF is nothing but the gain with feedback. AF is nothing but gain with feedback. And A is nothing but gain without feedback of the amplifier. Okay. And beta is nothing but the feedback ratio. Feedback ratio here. So once we are going with the positive feedback, we will get the gain of the feedback amplifier is gain without feedback divided by 1 plus gain without feedback times the beta or feedback ratio. Always in the positive feedback amplifiers, we will get, sorry, it is the negative feedback. Okay, it is the equation for the negative feedback amplifier. Always for the negative feedback, we will get the positive symbol in the denominator. And next, give the gain equation of the positive feedback amplifier. So the equation is same here. The thing is the sign will be different for the positive feedback. For the negative feedback, we will get the positive sign, and for the positive feedback, we will get the negative sign. And it is also a gain with positive feedback, and this is gain without feedback, and this is the feedback ratio in the positive feedback amplifier circuit. And next, what are the advantages as well as disadvantages of the positive feedback circuit? So while coming to the advantage, only one advantage it can able to provide the positive feedback, that is it is used to generate the oscillations. That is nothing but it is used to generate different waveforms, that may be the sinusoidal waveforms or non-sinusoidal waveforms. And while coming to the disadvantages, it is increases the instability in the amplifier circuit. That is nothing but it will not provide the stable gain across the output. And the bandwidth of the amplifier will be reduces when we connect with the positive feedback, and it will increases distortion across the output along with the output signal, and it is also increases the noise. So these all are the disadvantages of the positive feedback. So because of these many disadvantages in the positive feedback, in most of the electronic circuits, we will prefer the negative feedback to design the circuits. Though it is having these many disadvantages, in order to generate the waveforms, we are going to utilize this positive feedback only. Why? Because we don't have any option to generate the signals. Always by using the oscillator circuits only, we can able to generate the signals. If we generate the signals, only, we can able to check the performance of any circuit. But to generate the signals, we always require the oscillator circuit. To design the oscillator circuits, always we will utilize the positive feedback only. And next, what are the advantages and disadvantages of the negative feedback amplifier or negative feedback? So while coming to the advantages, it is the first and most required advantage here. It is the stabilization of the gain. Okay, it will provide the stable gain over all frequency ranges, and it will provide very high input impedance and low output impedance. These two are the basic requirements for the amplification, and it also improves the bandwidth of the system, and it will decreases the distortion as well as noise of the signal. Okay, these all are the advantages of the negative feedback. So these are the disadvantages of positive feedback are overcome by the advantages of negative feedback here. The only disadvantage of negative feedback here it is the reduction in the gain. Though it is providing the stable gain, but some amount of gain is reducing here. But even though gain is reducing, because of providing these many advantages, we are utilizing in the practical circuits. And next, what is sensitivity of transfer gain? So the transfer gain is nothing but the fractional change in amplification with feedback divided by the fractional change without feedback is called the sensitivity of the transfer gain here. So change in the amplification with the feedback to the change in the amplification without feedback indicates the transfer gain of the amplifier or sensitivity of the transfer gain of the amplifier circuit. And next, define oscillator. So oscillator is a circuit which is used to generate the output without providing any AC input signal to it. It is nothing but without providing any input signal. By applying only DC source, it can able to generate the signals. And always the electronic circuit which will convert the DC energy into AC energy at very high frequency range. So the basic thing of the oscillator is to generate the waveforms. That is without applying input or AC signal. And also it will convert the DC to AC signal. And next, define sinusoidal oscillator. So the name itself indicating the sinusoidal oscillator is used to generate the sinusoidal waveform as the output of the amplifier here. It is also called as a harmonic oscillator. So why? Because these sinusoidal, the lobes of the sinusoidal signal, we can call it as the harmonics. So that's why it is also called as harmonic oscillator. And next, define non-sinusoidal oscillator. So non-sinusoidal oscillator is used to produce the non-sinusoidal signals, that is other than sinusoidal or cosinusoidal signals. That may be the square wave signal or rectangular wave signal or sawtooth wave signal or triangular wave or pulse signals, step signals, etc. we can generate by using this non-sinusoidal oscillators. See, the function of the oscillator is same, that may be in the sinusoidal case or in the non-sinusoidal case. The only difference here it is, while designing the feedback circuit, we will utilize different elements. And next, define crystal oscillators. So these crystal oscillators uses the quartz crystals in the feedback circuit to generate the oscillations. So these are used to generate the output signals with a frequency range up to 10 megahertz. These crystal oscillators can able to generate the waveforms up to 10 megahertz range. And next, to define negative resistance oscillators. So why these are called as negative resistance oscillators means these are used to this will use it to generate the waveforms. Those are used to negative resistance characteristics of the devices, such as tunnel devices. They will utilize in the feedback path to generate the oscillations. So these tuned diode oscillators are the examples of negative resistance oscillators. And next, define degenerative feedback. So here, degenerative feedback is nothing but the positive feedback. Okay, which produces the output to be in phase with the input and increases the strength of the whatever the input signal we are providing across the input. And it is also called as degenerative or direct feedback here. So this is the another name of the positive feedback. So the function of this one is similar to the positive feedback here. And next, define sensitivity. So sensitivity is defined as the percentage change in the voltage gain with feedback, that is AF, to the change in voltage gain without feedback, that is del A. So variation in the gain with feedback to the variation in the gain without feedback indicates the sensitivity of the feedback amplifier. And next, what is transfer gain? So it is the ratio of output signal to the input signal here. Suppose if we are taking X0 as the output signal and Xi as the input signal, so the ratio is X0 by Xi, normal, the gain equation here it is. And next, to define the feedback factor beta. So it is the ratio between the feedback voltage to the output voltage of the amplifier here. So here the beta we are writing here it as the feedback voltage by output voltage. So in this case, this may be the voltage or current. The feedback voltage as well as output voltage may be voltage or current here. Always in the feedback amplifiers we are having the amplifier circuit as well as the feedback network. So here we will get the V0, here it is Vs. So this output we are giving to the input of the feedback. So the output of the feedback we will get it as Vf. So the input for the feedback is V0, output for the feedback is Vf. So that's why we are writing the feedback ratio as output of this one Vf divided by input of this one V0. Okay. So these values are depending upon the which type of input signal we are utilizing here and which type of output signal we are taking across the output here. In some cases, we may get beta equal to IF by V0. In some cases, we may get it as VF by IA. So that is depends upon the input and output parameters. And next, what is Flickr criteria? So Flickr is a scientist. He indicated some conditions to design the oscillator circuit to produce the proper oscillations. The two conditions are here. The total phase shift produced by the circuit should be 0 degrees or 360 degrees, as well as the loop gain or the magnitude of the loop gain must be always equal to 1 here. So in order to design any oscillator circuit, we must satisfy these two conditions in the circuit. Then only it can able to generate the proper oscillations across the output. And next, define desensitivity. So desensitivity is the reciprocal of the sensitivity here. So it indicates the factor by which the voltage gain has been reduced due to the feedback network. That is nothing but due to the desensitivity, the gain of the feedback amplifier is reducing here because it is always opposite to the sensitivity factor. And next, what are linear oscillators? So the oscillators which are used to generate the sinusoidal signals are called as linear oscillators. So linear oscillators are the other name for the sinusoidal oscillators. And next, what are nonlinear oscillators? So the oscillators which are used to generate the nonlinear signals such as square wave, triangular wave, and rectangular wave, and pulse wave, etc. are called the nonlinear oscillators. These are also called as multivibrator circuits to generate the signals. And next, what is audio oscillator? So if the particular oscillator circuit can able to generate the oscillations with audio frequency range, then particular oscillator we can call it as the audio frequency oscillator. So the example for audio frequency oscillator is RC oscillator. So these particular oscillators can able to generate the signals from 20 Hz to 20 kHz range always. So that's why these are named as audio oscillators. And next, what is radio oscillators? So if the particular oscillator circuit can able to generate the radio frequency signals, up to radio frequencies it can able to generate the signals, that particular oscillators we can call it as the radio frequency oscillators, are also called as LC oscillators here, or high frequency oscillators. Greater than 20 kHz signals this can able to generate here. And next, define Hartley oscillator. See here, Hartley oscillator is one of the type of LC oscillator. It consists of inductor as well as capacitor network in the feedback circuit, or else in between the input and output circuits we are having the LC network, that is the feedback network. So the feedback is achieved by the way of inductive divider here. That is nothing but in the feedback circuit it is having one capacitor like this as well as two inductors like this here. So one capacitor, two inductors are there in the feedback circuit, then we can call it as the Hartley oscillator, and it is the type of non-sinusoidal oscillator. And next, define Colpitt's oscillator. So here Colpitt's oscillator is also one of the type of the LC oscillator, and it is also consists of the inductive capacitor network in the feedback circuit or between the base and collectors of the circuit. So in this case, in the feedback network we are having one inductor and two capacitors, LC1, C2. So in the feedback circuit, if we utilize one inductor and two capacitors, means that belongs to the Colpitt's oscillator or non-sinusoidal or non-linear oscillator. And next, what are the types of feedback amplifiers? So here we are having four types of feedback amplifiers depending upon the which type of connection we are utilizing, or that is nothing but which type of sampling we are going to use in the output side and which type of mixing we are going to use in the input side. We can divide it as four types: voltage series feedback amplifiers, voltage shunt feedback amplifiers, and current series feedback amplifiers, as well as current shunt feedback amplifiers. And next, what is the purpose of mixer network in feedback amplifier? So the purpose of mixer network is used to combine the feedback signal with the input signal across the input of an amplifier. So it is used to mix both the feedback signal as well as the input signal. And next, what are the advantages of introducing negative feedback here? First thing is it will provide a very high input impedance and very low output impedance. These are the requirements for the proper amplification or faithful amplification. And next, list the four basic feedback topologies here. First one is voltage amplifier with voltage series feedback, and next transconductance amplifier with current series feedback, and third one is current amplifier with current shunt feedback, and trans resistance amplifier with voltage shunt feedback. That is nothing but for the 4 types of amplifier circuits, we are adding different feedbacks here. But for the 4 types of feedback amplifiers, when we are adding the different feedback circuits, we will get the 4 types of feedback topologies or feedback circuits here. And next, give the different types of feedbacks used in the amplifier circuits. Here we have 2 types of feedbacks, positive feedback as well as negative feedback, depending upon whether the input signal is adding or subtracting from the feedback signal to the input of the amplifier. And next, define the feedback factor. So the feedback factor we will indicate with beta. It is always feedback signal to the output signal. It is the ratio of feedback signal to the output signal. And next, what is loop gain or return ratio here? So the loop gain or return ratio is nothing but A beta in the gain equation. Generally, if you take the positive feedback or negative feedback amplifier, the gain is AF equal to A by 1 plus or minus A beta. So this A beta value, we can call it as the loop gain here. Okay, so this a path of a signal from input terminals through basic amplifier or through the feedback network and back to the input terminals form a loop here. So that particular gain of that loop we can indicate here it as the A beta. So it is also called as loop gain or return ratio here. And next, write down the advantages of RC phase shift oscillator. So it is very simple circuit. We can design in simpler. Why? Because it consists of only resistors and capacitors here. And it is useful to generate the oscillations of up to audio frequency range, and it will provide the sinusoidal signal as the output. And next, write down the disadvantages of RC phase shift oscillator. The frequency stability is very poor. Why? Because it is the low frequency oscillator. At low frequencies, the gain variations will be more. So that's why it is having poor frequency stability. And it is difficult to get a variable frequency across the output of the amplifier, output of the oscillator circuit. And next, what are the applications of crystal oscillators? So crystal oscillators are most of the cases we can utilize it to generate the clock signals for the microprocessor circuits and in the frequency synthesizer circuits. In order to set the desired frequencies, we can utilize this. And in the radio and TV transmitters for the tuning purpose, we can utilize this. So these are the different applications of the crystal oscillators. And next, write down the general applications of the oscillators here. So oscillators are in the radio receivers. In order to generate the local signals, it will utilize the oscillators here. And in the TV receivers, in the signal generators, as well as in the amplitude modulation as well as the frequency modulation transmitters, we will utilize these oscillators to generate different types of waveforms. And what are the types of RC oscillators here? Here we are having 2 types of RC oscillators. Those are RC phase shift oscillator as well as Wien bridge oscillator. So in the case of RC phase shift oscillator, we are going to utilize the resistors and capacitors to design the feedback network. But in the case of Wien bridge oscillator also, we are going to utilize the resistors and capacitor only. But in the form of bridge, we will utilize and more number of resistors and capacitors we are going to utilize in the case of Wien bridge oscillator compared to the RC phase shift oscillator. And these 2 oscillators are used to generate the sinusoidal signals. And next, what are the types of LC oscillators? So here we are having 2 types of LC oscillators. Those are Hartley oscillator and Colpitts oscillator. So in the Hartley oscillator, we will utilize 2 inductors and 1 capacitor. And in the Colpitts oscillator, we are going to utilize 2 capacitors and 1 inductor. And in the feedback network, we will utilize these elements. The amplifier is same for all the kind of oscillators. We will utilize either bipolar junction transistor or else field effect transistor to operate it as amplifier. And next, what are the applications of Hartley oscillator? In most of the cases, Hartley oscillators are used as local oscillators in radio as well as TV receivers and in the function generators to generate the non-sinusoidal signals. We can utilize this Hartley oscillator. And next, what are the advantages of Hartley oscillator? So most of the cases we will utilize for the tuning purpose in the televisions in order to change different channels. We can utilize this Hartley oscillator in all the remote controllers. We will utilize the Hartley oscillators for the tuning purpose. And it can operate over a wide frequency, typically from few hertz to several megahertz. So this can able to generate the signals up to several megahertz range. And it is easy to change the frequency by means of a variable capacitor. By using the capacitors, by using different capacitors, we can able to change the frequency of oscillations in the case of Hartley oscillator. And what are the advantages of a crystal oscillator? So it is having very high frequency stability compared to the remaining all the oscillators. And the Q, the operating point of this oscillator is very high and it is very stable. So these all are the advantages of the crystal oscillator here. So in this session, we discuss the different terms as well as the definitions which are utilized in the different feedback amplifiers as well as different oscillator circuits. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.